All right, so thanks for the invitation to the RSNOG conference. My name is Oliver Gasser. I'm a postdoctoral researcher at the Max Planck Institut for Informatics in Germany. And today I'm going to present a short excerpt of our findings when we looked at the so-called lockdown effect, namely the implications of the COVID-19 pandemic on internet traffic. So let's get started. As you all know, right around in the middle of March, most of the population of the world went into lockdowns, which means that people should stay at home. They were working from home. The teaching shifted to home, as well as the learning shifted to home, and even some of the social life moved to the homes of the people. And we asked ourselves, since the internet is essential in all of these efforts, how well does it actually cope? And in order to answer that question, we analyzed quite a lot of data, namely from different networks. The first one being a large European internet service provider, which is what we call an edge network. And then we also looked at core networks, namely networks more located in the core of the internet. And these were three internet exchange points, one in Central Europe, one in Southern Europe, and one at the US East Coast. And finally, we also looked at an academic network, namely Redi Madrid, which is a university network in Spain. And to analyze all of that data, we assembled quite a large team. So we were 12 people from different research institutions and universities, and also companies to analyze the data. So the first topic that I want to share with you is how did the traffic overall change in different types of networks. And what you see here is the traffic volume across time. It starts in January 2019 and goes all the way to June 2020, so right around 1.5 years. And on the x-axis in the lower part, you see the calendar week. And on the y-axis, basically, you see the traffic volume. So whenever the line goes up, this means that traffic increases. Whenever the line goes down, this means that traffic decreases. You also see a vertical line where there is the change between 2019 and 2020. And we've also identified the date of the COVID-19 outbreak in Europe, and then the initial responses right around March and the lockdowns. So the first line that you see here is the blue line, which is the internet service provider, the European internet service provider. And what you see with this line is that right around the lockdown, we see a 30% increase in traffic, which is quite significant because normally this would span over multiple months, if not even a year. If we compare this to the internet exchange point networks, we see a very similar behavior. And for most of them, the traffic levels remain elevated even after some of the lockdowns have been lifted. Now, a completely different network which we investigated is a mobile operator network, which you can see in orange here. And what we see there is that since people were forced to stay at home, they were not going outside anymore so much. So they used the mobile network less and less. And in that case, we see actually a decrease in traffic once the lockdown was put in place. And once some of the restrictions were lifted in mid-April or so, we see the traffic picking up again because people were moving outside more again. So we see that there is actually quite a clear correlation between the lockdown and traffic levels changing. And now that we've seen kind of how the overall picture looks like, let's look at how traffic patterns actually change within weeks. And we want to look at how workday traffic patterns differ from weekend traffic patterns. And what you see in this graph is the traffic volume, how it is distributed across the day. And each bar basically is the traffic volume for a single aggregated hour of the day. And the blue bars in this graph show the traffic levels before the pandemic of Wednesday, so a typical working day. And what we see here is that there is normally a strong increase of traffic in the evening hours, when people come home from work, they come home from university, from school, and they use the internet more than they use it during the day. And if we compare this to a weekend day, also before the pandemic, so Saturday, February 22nd, we see that the traffic is more evenly distributed over the day. So more traffic, we see actually more traffic during daytime. Now let's have a look at how this changes during after the lockdown. So we investigated how does a working day look like after the lockdown, and we took Wednesday, March 25th, and we see that after the lockdown, the work days look much more like weekends than they actually look like work days before the pandemic was put into place. And yeah, now I have shown you this one example for these specific dates, but how does this look like in the overall picture for a longer period of time? And what we did here was to basically classify each day whether it looks more like, whether the traffic pattern looks more like a workday pattern or whether it looks more like a weekend pattern. And on the upper part of the graph, which I will show in a second, you will see weekend days, and on the lower part of the graph, you will see work days. And whenever the classification was done correctly, for example, a Wednesday was classified as a workday, the bar will be shown in blue, and if the classification is done incorrectly, the bar is shown in orange. So what we see leading up to the pandemic, almost all of the days are classified correctly, namely working days are classified as having a workday-like traffic pattern, and weekend days have a weekend-like traffic pattern. Now, when once the lockdown comes into effect, this drastically changes. As I've shown you in the previous graph, the working days actually start to look more like weekend days. That's why the working days from the lower part move to the upper part, and the color changes to orange because they're basically, they don't behave as they should behave. If we look at it in terms of how does this change with regards to moving on in the direction of March, we see that the behavior starts to kind of normalize a little bit. So it's recovering, and the days start to behave more like they should when looking at traffic patterns. This is obviously because people, and some of the restrictions have been lifted, and people are moving outside again, and regular behavior more or less starts to pick up after some of the restrictions have been lifted. So in the first part of the presentations, I've shown you how the overall traffic changes. But how does this look like for a specific application? And that's what I'm going to show you in this part. And what we did to classify traffic by application was and apply a classification based on transport ports and source and destination autonomous systems. And what you see here, this is basically a heat map. We have several different traffic classes, which you can see on the left side, for example, web conferencing, collaborative working, email, video on demand, gaming, social media, education, and CDN traffic. And this is what we call the base week, which is a week that we chose in February, where we see normal traffic patterns and not influenced by the lockdown. And what we can see here, basically, how you can read this graph is the more orange you have, the more traffic during a specific hour of the week. And what we see is that email, there is not a lot of email traffic, but most of the email traffic occurs during working hours, which makes sense because then people are working and they're sending more emails compared to, let's say, in the evening hours or during the night. Video, gaming, and social media see the most traffic during the evening hours. So when people come home from work, come home from school, come home from university. And also an interesting fact, we see hardly any web conferencing traffic. And this is, of course, going to change when we go into the lockdown. So let's actually have a look, how does this change? And what we did here was to compare our our March week, a week in March, to the base week, which is the week in February. So basically we did a diff, right? So we made a difference. And all the blocks that have a yellow, orange, or red color, this means that there has been an increase in traffic. and all the colors going into the green and blue, this means that there has been a decrease in traffic. And I will focus on only a part of the graph because otherwise it would take too much time. And what we see in March, that there is an increase in web conferencing, video on demand, and gaming traffic, and there is also a partial decrease in CDN and educational traffic. If we now go into April, so when the lockdown was in full effect, we see a very strong increase in web conferencing traffic, which is the uppermost bar in this graph, and again, a decrease in CDN and social media traffic. And the same is basically true for June, where again, we see a strong increase in web conferencing and a decrease in CDN and social media traffic. Another important application when working from home is a VPN in order to connect to your university infrastructure, to your company infrastructure, and so on. And we wanted to have a look at how does VPN traffic change during the lockdown, and we identified VPN traffic using two techniques. The first one being a simple port-based technique, when we know that there is a well-known port, a protocol combination exclusively used by a VPN service, then we would say, okay, this is VPN traffic. But VPNs also use TCP/443, for example, to tunnel their traffic, which is obviously also used for HTTPS. So we needed also to distinguish between HTTPS traffic and TCP/443 tunneled VPN traffic. And what we did there was we leveraged domain data, and we extracted basically VPN labels and then mapped those to IP addresses. And we also removed the same IP addresses if they had the mapping from the .dot domain. And in this graph, you see kind of the normal VPN traffic behavior as it was in March. On the upper part of the graph, you see the VPN traffic for working days, and on the lower part for weekend days. So generally, we see more VPN traffic on working days, as you would expect, as people are more likely to work during the working days. If we compare this to March, so how does this change? We see about 200% increase in VPN traffic in March, mostly during working hours. So the stronger increase is actually during working hours and during working days compared to the lower part of the graph, which is the weekends. So there is still an increase during the weekends, but not as much as during working hours, during working days. If we compare this to the following month, which is April, we see that there is a slight decrease there, and the same is true for June, where again we see a slight decrease in VPN traffic, although the traffic level still remains elevated compared to, if you compare it to February. Now we've looked at mostly where traffic increases. The last part of the presentation is I want to show you the educational traffic and how that changed. And here you see again the time progressing on the x-axis. And these are the daily connections for specific traffic classes. And the green one is incoming web traffic. So web traffic going into the educational network. And that sees also an increase because since more students are using online lecturing and they're downloading slides online instead of going to the lectures, you would expect that web traffic increases. The same is true also for VPN traffic, since the people working at the university or the research institutes are not on the campus or in the offices anymore. They would again connect via VPN, and we see VPN traffic also increasing, and we see this nice working day weekend patterns where you have more traffic during the working days. But it completely changes if we look at, for example, quick traffic, in this case, outgoing quick traffic. And quick is a transport protocol, which is, for example, used for video streaming, but also other purposes. And this is an effect because people were not on the campus anymore. They were staying at home. So the outgoing quick traffic saw a large decrease. And this shows that the absence of users actually leads to a decrease in traffic. So to summarize, what did we find? We found a 15 to 30% increase of overall traffic within just a few days. And the work days actually started to look more like weekends when we look at traffic patterns. We saw an increase in remote work, education, VPN, and video conferencing traffic. And the absence of users, as you've seen in the educational network, actually leads to a decrease in traffic. You can find much more if you're interested in this at a paper that we published at the Internet Measurement Conference this year, which is called the Lockdown Effect. There we look at how does the transport protocol distribution actually change, and we have a more in-depth view of different traffic classes, and we also compare hypergiants versus non-hypergiants. You can, if you're interested in that, feel free to reach out to me. You have the email address down here, and the other web address is basically the link where you can download the paper for free. Thanks, everyone. And if there are any questions, I'm obviously available to answer them.